Hello, everyone. Now we're going to go through one of my favorite application of system of linear equation, Leontief's model. And I think the best way to go into Leontief's model is to really jump into like a question and try to make sense of that question and try to solve it with all the tricks that we have. Friendly warning here, if you're looking at the solutions of my completed note, I typically just use the Gauss-Jordan elimination algorithm to get to the solution. Here, I'm going to show you both ways. I'm not going to do all the computations, but when I say both ways, sorry, I mean using the Gauss-Jordan elimination algorithm, and I think this is the way if you're doing this on a test using Cramer's rule. I think Cramer's rule here is just shines bright like a diamond in the sky. It's really the way. Anyways, so let's look at this problem. And basically, this is a text problem with a very business oriented application. But yes, it's a fat text. You need to read the fat text, define the variables that we're trying to compute, create a system of equation. That system will be, of course, in a linear algebra course, a system of linear equation, and then we're going to solve it. So here we go. Let's just jump into the example. So my first example that I want to go through, in a province, suppose there's three sectors of economic activity. Suppose we have some oil, we have some electricity, and we're constructing also automobiles. So we have three different sectors, and we're producing in these three sectors oil, electricity, and automobiles. So this is how the businesses are linked together, or the sectors are linked together. First, to produce 1 unit of oil, you actually need to burn zero point 0.1 unit of your own production of oil. You also need zero point 0.3 units of electricity, and you need zero point 0.1 unit of automobile. So the idea, like if you're drilling some oil, you're probably using some machines. So these machines like trucks, so automobiles, these trucks are burning oil, and maybe in order to produce oil, you also need some equipment that is using electricity. So that's the idea. So to produce oil, you need oil, electricity, and also some cars. So to produce 1 unit of electricity, you need to burn some oil, so 0.25 units of oil, zero point zero 0.04 unit of electricity, and zero point units of automobiles. So again, the idea here, so let's say you're building a dam in order to gather some electricity. Well, you're going to be using again machines, so automobiles that will burn oil. And again, you're probably going to use electronic equipments. So this is not a very efficient place, I guess. But anyways, it's using zero point 0.4 units of its own electricity to produce 1 unit of electricity. And then to produce 1 unit of automobile, you need zero point 0.2 units of oil, zero point 0.5 units of electricity, and zero point 0.1 unit of automobiles. So again, you're building cars, so you probably need, some machinery that is using oil. You're building cars, so you're probably using a lot of machinery that is using electricity. And you're using trucks or whatever to move these cars around, so you're also using the production of your own business. So here, what we want to figure out is we want to compute the production levels of all these three sectors if the province, if your province here needs to export 14 million. So here, export is very crucial here. Export 14 million units of oil. We need to import 17 units of electricity. And as you can see in our descriptions, we were using a lot of electricities in all our sectors. So actually here, we're going to be importing some electricity, some electricity, and we're going to be exporting some cars. So one thing I can see from this question is this province is really good at making oil and cars, but it's not as good as making electricity, not enough for its own little internal demand. So it needs to import some of that some of that electricity from the outside. So what we want to do here, we want to compute the production levels of all three sectors in order to satisfy all the demand demanded by the three sectors of activity within the province and also the external demand. So here, the first thing you always do, there's always a lot of marks just for that. So let PM be the number of units of oil in million. I use M here because in French we say mazout. Okay, so that's why there's an M there. Let PE be the number of units of electricity. I will be doing this in million just to make the numbers a bit smaller and easier to work with. And PA will be the number of units of automobile. All of these things will be in million. So again, this PM, PE, and PA, this is what we're trying to find. Those are the variables. I want you to always first define the variables. You can use X, Y, Z, of course. I like to use P subscript, whatever my name of my sector of activity is. So PM for production of mazout, PE for production of electricity, and PA for production of automobiles. Again, it does not really matter what letters you're using, but I want you to be clear in your solution. The first step is to define clearly using a nice sentence. What are the unknowns? What are you trying to compute? I think the toughest part with this question is really constructing the system of linear equation. And here, the trick, there's really two ways to do this. You can just learn the trick, and I'll show you the trick in a moment. I'll try to explain to you where these numbers are going. I think it will make more sense if you do understand what's going on, but if you don't, there's a nice little trick. Read one sentence, and it's one column of your system. But I'll try to do my best to explain where the numbers are going. So the first thing I'm going to do in order to explain this is I'm going to go sentence by sentence, and I'm going to use specific values to explain what's going on for specific level of production. So for example, suppose we look at our oil sector, and suppose we want, so just as a remark here, suppose we want to produce, and let's use a number that is nice to work with. Suppose we want to produce, what? Let's say we want to produce 100 units, well, 100 million units, but whatever, 100 units of oil. Okay, suppose we want that. Okay, so we want 100 units of oil. So according to this first sentence, this first recipe, what do we need to make 100 units of oil? Well, for every units of oil, I need 0.1 unit of oil. So here what I need first is 0.1 times 100. So for every unit, because I'm making 100 of them of oil, I need 0.1 units of oil. So I need 10 units of oil. So that's the first thing that I need here. I need 10 units of oil in order to produce 100 units of oil. And then what do I need? I need 0.3 units of electricity for every single unit of oil that I want. So how much units of electricity do I need? Well, it's going to be 0.3 times 100 units of electricity. So which is, in this case, 30. So this number is 30. Let me just write it somewhere. Just equal to 30. You will not see the 30 just appearing next to it by the magic of editing. So 0.3 times 100. So you need 30 units of electricity. So 30 units of electricity. Oh my God. Hello, iPad. Hello. So 30 units of electricity. And finally, what do we need in terms of automobiles? We need 0.1 units of automobiles. So it's 0.1. So the last thing that we need. So and 0.1 because we want 100 units of oil and we need 0.1 units per unit produced. So it will be 0.1 times 100. So we also need 10 units of automobile. The reason why I take the time to write that down is to really see what is used in the production of these 100 units of oil. So I need 10 units of oil, 30 units. So let's just highlight them. So I need 10 units of oil. I need 30 units of electricity, and I need 10 units of automobile. So the reason why I'm writing what I need to produce those 100 units of oil, so here clearly put, I need 10 units of oil, 30 units of electricity, and also 10 units of automobile to produce 100 units of oil. Now, in general, if I need to produce PM units, how much of each sector do I need? So, how much of the production of each sector do I need to produce PM? So, here the idea, just like we need 10 units of oil to produce 100 units of oil, so we did zero point 0.1 times 100. In general, I will need 0.1 times PM units of oil in my production. So in the production, so PM is the total. So this PM here is the total amount of production. So it's what we need. I wrote this here, like this is what we need for all sectors and also for my export and import. So if I'm producing PM units of oil, I will need to burn zero point 0.1 PM units of oil. And now this is where things are getting trickier. This is where people are, they typically make mistakes. I also need 30. So for 100 units of oil, I need 30 units of electricity. So this is a demand on the electricity sector. So this number needs to be extracted, needs to be counted in the level of production of electricity. So for every units of oil that I'm going to produce, 0.3 times PM is going to be how much units of electricity I need in order to produce that number. So that 0.3 PM, just like we did 0.3 times 100 earlier, that's a number that I will put in the production level of my electricity. So here, those numbers that you read or that you get from the first sentence, they are aligned as a column inside this system of linear equation. And then finally, so in order to produce 100 units of oil, I needed 10 units of automobile. So in general, if I want to produce PM, I need to borrow from the production level of automobile 0.1 times PM. So one thing to notice here is that this first sentence with the numbers, the 0.1, 0.3. So if I look at my numbers, so I had a 0.1, 0.3, and 0.1 in my first sentence. In that first sentence, these numbers were aligned as the first column. Some people, they just learn that trick. Whatever you read in the first sentence will go in the first column of that system of equation, and that will work very well. But when you understand why, it really makes it a lot nicer. And now the idea is after you understand one of them, you can just rinse and repeat. So for the electricity, for example, if I now want to produce PE units of electricity, well, I will need for every unit PE, I will need to multiply it by 0.25 to figure how much oil I need. And this will be going to be counted in the production level of oil. So 0.25 PE will be what I need from the production level of oil to produce PE units of electricity. And then to produce 1 unit of electricity, I need 0.4 units of electricity. So if I produce if I want to produce PE units, well, I will need 0.4 PE units of electricity. So here that 0.4 goes into the second equation. So for every single unit that I want, I need to burn a fraction of it for its own production. And this goes into the production level of electricity. And then for every single unit of electricity produced, I need 0.15 units of automobile. So here, the idea is these equations, you keep the same ingredients or the same, like the same material. So these equations are really computing how much material you need per sector. And then when you read one sentence, I am presenting how much units I need for every sector. So that's why they're not in the same equation. And then finally, so for again here, I like to highlight those points. So if I read my first sentence, my second sentence, you can see the point 25, the point 4, and the point 15 are now as a column in my system of linear equation. And then for the last one, so if we're producing PA units of automobile, for every units, I'm burning 0.2 units of electricity. So here we get plus 0.2 PA. And then we're burning 0.5 units for every PA. We're burning 0.5 units of electricity. So it goes in my electricity formula. And we're burning 0.1 units of automobile. And now we have so this is all the material that I need for all my sectors. These PM, PE, and PA. These are also known as the internal demand. So you have three sectors of activities. You're producing three things, and you need some of the material from the other sectors. But typically, you don't want a business where you're just kind of feeding onto each other. You want to be able to import, or if you're missing some material, you want to import that stuff. So here we need to take into account like the import and export. So here we're saying that the province is going to export 14 million units of oil. So this needs to be produced. That 14 that you want to export needs to be produced. So that number goes at the end here plus 14. So that PM equation computes how much units I need for the production of oil, how much units you need for the production of electricity, how much units you need for the production of automobiles, plus how much units you want to export. Meanwhile, for the second number, we want to import 17 million. So this amount does not need to be produced, so it's going to be given to us. So actually here, when you import, that number now is actually a minus. So minus 17. So import negative because you don't need to produce that number. And then finally, we are also exporting 30 million. So we need to produce that amount that we want to export. So it's going to be plus 30 million. So in a nutshell, every time you see export in your equation, it's going to be plus, and every time you see import, it's going to be minus. So we have our system of linear equation. You can actually write your system in matrix form. So simply put the first vector that you have in your system, that's your production level. So PM, P, PA, that you're just rewriting as a matrix, column matrix. All your internal demands, point 1, point 3, so let me highlight them at the same time. So from the first sentence, point 1, point 3, point 1. From the second sentence, point 25, point 4, point 15. And then for the last sentence, point 2, point 5, and point 1. And that matrix, this is what we call the consumption matrix or the internal demand matrix. And that matrix is being multiplied by PMPPA. So again, if you do your matrix multiplication, that would explain that part of that system. And then we put all the demands in a vector that we call the demand vector. And this is like the Leontief model in matrix form. And if you want to solve it, you can use a theory where you build the augmented matrix. And in the theory, they say you're solving I3 minus C augmented by D. I find this is a bit magical. My advice to really fully appreciate what's going on here is to look at these equations and just bring all the variables on the left side. Like for example, the first equation, if I bring all the equations on the left side, all the variables, sorry, on the left side, what do I get? So I have PM, so this is what we had on the left side. But now the 0.1 p.m. goes on the left side as minus 0.1 p.m. Let me just rewrite it. So 0.1 p.m. minus 0.25 PE minus 0.2 PA. And you keep the constant on the left, just to have it in standard form to have our little system here. And here, you do the exact same thing for the left, means for the second equation. So I'll write the PAs first, so you get minus 0.3 PM. So my 0.3 on the right side goes on the left as minus. Then I have my plus PE that was already there on the left, minus 0.4 PE. The idea here is I'm trying to group together the variables that are the same in order. And then finally, I have my minus 0.5 PA that goes on the left side as a negative, and I keep the minus 17 on the right side. And then finally, so I bring the minus 0.1 PM on the left. So be sure to follow that. I'm just rewriting these equations, bringing all the variables on the left side, minus 0.1 PM plus minus, every time you move things around, so you get minus 0.15 PE, so from the right to left. And then you get plus PA, that was already on the left side, minus 0.1 PA, and this needs to be equal to 30. So I keep all my constants, basically the external demand numbers, on the left side. So now when I'm building the augmented matrix for that system, this is where you're going to see these numbers appearing. So the first number of your augmented matrix, this is now in standard form. So if I bring those PMs together, 1 PM minus 0.1 PM, that's 0.9 PM. And then you get minus 0.25, minus 0.2, augmented by 14. If I read the second equation, I have minus 0.3, 1 PE, this is a little computation here, 1 PE minus 0.4 PE will be 0.6, minus 0.5, and then this is augmented by minus 17, and then you have minus 0.1 for the third equation, minus 0.15 in front of PE, and then PA, 1 PA minus 0.1 PA, that's 1 minus 0.1, that explains that 0.9 there, augmented by 30. I don't know for you, but for me, I find this version of the system of linear equation makes a bit more sense instead of just learning this as, oh, construct this augmented matrix as the identity matrix minus C augmented by B. It works very well if you have a good memory, never touch alcohol or drugs in your life. That might be a way for you to do it, but I don't think it's the best way. I think the best way is to really take your system that is presented initially as PM equal to some stuff, PE equal to some stuff, and PA equal to some stuff. When I say some stuff, I mean the internal demand plus external demand, so for each sector of activity. And then you rewrite this system of linear equation in standard form, where you bring all the variables to the left and you keep the constant to the right. And then you just write the regular augmented matrix that you're going to be using, either using the Gauss-Jordan elimination algorithm, or my advice is to try Cramer's rule. Here, of course, I've done these things using the computer, but if you do Gauss-Jordan, not an easy one here. My advice is probably to multiply everything by 10 or 100, do a couple of swapping in order to do this. You don't need a row reduced echelon form, by the way, but if you do it in row reduced echelon form, this is what you would get. So the first column is for PM. Let me just write on top. So I have one pivot for PM, one pivot for PE, and then one pivot for PA. And when you read this system of equation, the first equation gives you that PM is equal to 30, PE is equal to 20, and PA is equal to 40. So you have your level of production per sector that will satisfy the internal demand and also the external demand. But again, here, big fat warning. Gauche Jordan, not the easiest way to do it. My next example, I will show you the steps using Gauche Jordan. Here, I only did it by using the calculator online. I mean, it's a good practice if you can do this by using Gauche Jordan. You're basically a black belt in the Gauche Jordan elimination algorithm. But a very sweet and a very important remark down here is that for these questions, and my advice for tests, so tests, the first test and the final exam, use Cramer's rule. These questions are 10,000 times easier if you do it using Cramer's rule. So the idea here is that if I have that system of linear equation to solve and I want to use Cramer's rule, I will just do the computation for one level, but my advice is to double check that it works for every single level. The first thing you do is you compute the determinant of your coefficient matrix. So I have my coefficient matrix here. And if you compute the determinant, this is a 3 by 3. I'm not saying that this is way easier. You still have to struggle computing that 3 by 3 determinant, which I don't have the details here. Remember, when you compute the determinant of a 3 by 3, you have to rewrite the first two columns and go and draw your arrows for the plus and then the anti-arrows for the minuses. Or if you've seen cofactor expansion, or if you know how to compute determinants using whatever tricks for a 3 by 3, please do it and double check that this determinant is actually 0.3175. And then suppose I want just to compute the production level of oil. I'm going to replace my first column by the augmented column, which is 14 minus 17 and 30s, or the external demand vector. And then you have to compute the determinant again of this brand new matrix. And please do it. This is a very nice, slightly more challenging example in terms of computing determinants. Double check that you will get 9.525. And then if you want the production level of oil, if you take the ratio of that determinant of A, where you replace the first column by D divided by the determinant of the original matrix A, you get 30 again. Okay, so, and you can do the exact same thing, replacing the determinant, the second column by the D, compute the determinant, divide by that 0.3175, and same thing, and verify that this will give you, after you get your 30, this will give you 20, and I think I wrote 4 earlier, I meant to write 40 here, which is the worst feature ever. Okay, so make sure you know how to get these numbers using Cramer's rule. I think it's the best way to do these questions. All right, this video is getting a bit long, so I'm just going to cut that first example about the Leontief model, and I'll do another example in the next video. So for that example, that's it. That's all. Bye-bye.